All right, so today we're going to talk about radicals and simplifying radicals. So I'm going to cover a lot in a little bit of time, so I need everybody to follow along, okay? First of all, this symbol that we see here, and let me just stretch this out for a minute so we can see it. This symbol is called a radicand. Is everybody with me? Generally, when we see it, it represents like a square root, okay? So if I'm asking you about square roots or cube roots or any type of root, this is the chart that I want you to refer to. So what do I mean? So let me just give you an example of something real quick. I want to show you where the square roots and all this kind of stuff come from. So if I were to give you a square, what's true about a square? All sides are equal. It has four sides. It's a quadrilateral. But what's true about the measure of the sides? All the sides are congruent, right? They're all equal. So if I had, let's say this would be 2 by 2. Everybody with me? Everybody paying attention? So that means the length of this is 2, 1, 2. And the width of this is 2, 1, 2. Y'all with me? So 2 units by 2 units is going to give me how many squares? 4. So the area of this figure would be 4. But how did we get 4? Because we did length times what? Width. And length times width is 2 times what? 2. That is the same thing as saying, what is the square root of 4? What is the square root of 4? It's 2. But why is the square root of 4 2? Because 2 times 2 is 4. Are y'all following me? Square roots are numbers that when you multiply them by themselves, they give you the product. Are y'all following me? So if we go back and look at this list that we were on just now, if I have a square with the area of 4, then each side was what? 2. If I have a rectangle, or not rectangle, a square with an area of 9, that means each side was what? 3. Are you following me? Why? Because 3 times 3 is what? 9. Are y'all following? So some number times itself, some length times some width, is going to give me the space inside, which is the area. Does that make sense? Yes? Let me give you another example of that, because I see some faces. So what if I gave you, let's say, another square, right? And inside the square, let's say I gave you, this is a 4 by 4, right? Well, what would be the area inside? How many squares would I end up with inside? 16. So if I do this, just watch. This is 1, 2, 3, 4. Y'all with me? This is 1, 2, 3, what? 4. So how many do we got all together? 4, 8, 12, 16. But the easy way to get that is 4 times 4. So if you give me a side of 4 on a square, you're going to end up with an area of what? 16. Is everybody following me? So if I ask you, what is the square root of 16? You would tell me the square root of 16 is 4. If I told you I had a square with 16 boxes, you would tell me that each side must have measured 4. Does that make sense? So the relationship between squares and square roots is the same thing as the relationship between the side of a square and its area. Does that make sense? Yes? Now let's go a step further. What if I said to you, oh, why this on? Erase. Oh, I know why. You gotta do this. All right, so what if I said to you that I had this figure? What am I constructing? Cube. Anybody know? Cube. Right? Does that make sense? That's a cube. One-dimensional, two-dimensional, flat like a desk, or three-dimensional? Three-dimensional. Three-dimensional just means I have 3 measurements. Are y'all with me? So you got a length, you got a width, but you also have a what? A height, right? So the space inside this figure is not called area. On a flat surface, it's called area. But in a 3D figure, it's called volume. So now what if I told you that I had a volume of, say, 8, right? If I have a volume of 8, then that would mean how much was my length, my width, and my height?
2.
It had to be what? 2. Why? Because 2 times 2 is what?
4.
4, and then 4 times 2 is what? 8. So if we had a volume of 8, say, units cubed, then that means the fact that it's units cubed means I multiply 3 measurements to get it. And if it's this would be a not pyramid, this would be a prism, a square prism, right? Or a regular prism. What do we mean by regular? If it's regular, that means all the measurements are what? Equal. Are y'all with me? So if this is a regular prism, then what would be the measurement of each one of these if they all got to be the same to end up giving me 8? It had to be 2. Because 2 times 2 is 4, and 4 times 2 is 8. Does that make sense? Why am I showing you this? Because that's the same thing as cube roots. If I asked you, what is the cube root? Now watch the difference between what I'm showing you and what we did before. How is this different from what I did before? This has what here? A 3. Now, if we had to put a number here, what would the number be?
2.
A 2. But we usually don't put the number 2 because this means to the square root, right? But when I put a 3, that means I'm not looking for a number that's been multiplied by itself twice. I'm looking for a number that has been multiplied by itself 3 times. So what number times itself 3 times is going to give me 8? That number is 2. So the relationship between cube roots and cubes, between cube roots and cubes, is the same as the relationship between the sides of a 3D figure and its volume. Are y'all following me? Is everybody following? Yes? What is it that I have to multiply by itself either twice or 3 times to get that value? Now, I want to take you to what it looks like here, right? Everybody grab your calculator real quick. Let's go back here. Now, this part is very simple. Since they've allowed you to use calculators, it's easy to get your numbers. You don't have to think of these numbers no more. They give them to you, right? You just use your calculator. As long as you know how to operate it, you can find them. So what if I wanted to find the square root of 16? I just want to practice what we would put in. Charles, you doing what I'm doing? Okay. So what am I going to put in the calculator? 16.
Square root.
And square root symbol is where? It's right here. Y'all see that? This squares it. So this would do 16 times 16. This is square rooting. It says what number times itself will give you 16. Y'all with me?
Yes.
So we hit the square root symbol, and what do we get?
4.
We get 4. Is everybody following? You are going to have questions on your EOC where you're going to have something in a radical, and they're going to ask you to find the square root. Are y'all following me? I want you to know the difference between the symbols. Are we good here? Yes? Now, what if we're here and they giving me this, an 8 with a 3? That means they want to know what number times itself 3 times would give me 8, right? Well, same idea. Instead of it being called square root, it's now called cube root because I'm looking for a cube. So what am I going to put in?
6.
I'm going to put 8 because that's the number, right? Now, you're telling me to press second because we're going where? To the cube root. Where is cube root?
0.
At the 0. Excellent. Do everybody see that? You see that? It's the cube root. Y'all see that? So we would press 8 and then we would press second so we can access that key and hit 0. And what do we get?
2.
2. It tells us that 2 when multiplied by itself 3 times give you the 8. Everybody got it?
Yes.
Are there any questions? Give you the 8. Does everybody understand that?
Yes.
Now, here's another way. I don't really use the 0. I use one button for everything. So watch what I do. I'm going to go back to the square root of 16. Pay attention. Do you see this key right here above y to the x? Y'all see that? That is taking the root of any number. So if they ask you the 5th root and put a 5 here instead of the 3. If they ask you the 7th root, everything can be found with that key, right? This one is limited to the 3rd root, the cube root. This one is limited to the square root, but this one takes any root. Does everybody see that key? So watch what I do. I'm going to do 16, just like I would have done the first time. But now I'm going to hit second, and I'm going to hit that key. But I'm finna tell it now what root I want. I want the square root, so I'm going to put a 2. And now I'll press equal. And what did it give me? It gave me the 4. Are you following? Now you can just do 16 and go straight there. Or you can do the 8 and just do that second key with the cube root. But I always use this one because I can use it for any root. Are y'all with me? Now I'm going to do the cube root and see what happens. Let's press 8. And then I'm going to press second. I'm going to access the any root key. And then I'm going to put what? 3. Because I want the cube root this time, right? So I'm going to press 3. And then equal. You got to press equal out there. And what did I get? You get the 2. Are y'all following?
Yes.
Yes? All right. So this is how we can use this key, square root key, or cube root key, depending on what they ask you, to find any root you need to find. One of the very important things is going to be not just know how to do this math, but know how to use these tools they give you, right? Because if I can use this instead of me sitting there trying to think of what the number is, that saves me time to spend more time on other problems. Are y'all with me? So let's make sure that we are using this to answer these questions, okay? Now, why am I giving this to you right now? Because we have done quadratic formula, right? And I don't know if you guys remember, but on that last quiz that I gave you on quadratic formula, right? The very last question, the answer was left in a radical, right? And they wanted you to simplify the radical. But you guys didn't know how to do that. I mean, one person in the class got it right. Yeah. But everybody else got it wrong on purpose because I knew it was going to be wrong, right? But there are sometimes if you're able to simplify a radical, then you get more points for that. It's worth more, a higher level of points than it would be if you can't simplify it, right? So I want to make sure you guys understand how to simplify a radical. Are you all good with me? Yes? All right. So I'm going to go back to, let's go look at these notes that I gave you first. Which one did I have? Oh, no. Cancel that out. All right, let's look at this. So real quick, I just want you to play with it in your calculators. Grab your calculator real quick, and I want you to tell me what you're going to put in your calculator in order to find the answers to these questions. So for example 1, it says square root of 16. I know the square root of 16 is what? 4. And I know that because 4 times 4 is what? 16. And I also know that because if I got an area of a square that's 16, that means each side must have been what? 4. I know that. But I want you to play with it in your calculator. What do we put in our calculator in order to evaluate that? What are we going to put in? Walk me through the steps. 16. Square root key. Now, can we do what Jeffrey just said and hit second? Yes. But do we have to? No. So we can just hit this key and we get what? 4. Everybody with me? Yes? Let's do it the way Jeffrey was going to explain. Very good, Levante. Tell me, Jeffrey, what to do. You can't sit by that door if you're going to keep looking out that window. Go ahead, baby. Tell me. 16. Second. Y to the X key because you want what's above it, right? 2. Excellent. Because I'm taking the square root, right? And then you hit equal. And then it gives us the 4. Everybody got it? Yes? Listen, if I tell you to do it with your fingers, there's a reason I'm telling you to do it with your fingers. Do y'all know that there's something called muscle memory? Yes. Yes? And sometimes without even trying, your fingers know what to do just because you've done it so many times, it can do it on its own. So when you're thinking about something, your body goes into motion based off habits, right? So I want you to play with it. When I'm telling you to pick up that calculator and press them buttons because your brain will remember that when it's time for you to use it on your own, okay? Now, what do we do for the now? Now look at this other example. The second example. I want to look at that. It says the square root of 24. So now I want you to look at that. It says the square root of 24. Now, if we look at our list, do we have any 24s under square? No. There are none. So let me explain what a perfect square is or a perfect cube is. A perfect square or perfect cube means that the square root is a whole number or the cube root is a whole number. Are y'all following? Put this in your calculator. Put in your calculator 2.25. I want to show you what I'm talking about. 2.25. And now I want you to hit the square root key. What do we get? 1.5. Now, 2.25 is a square. It has a square root. Every number got a square root, right? Some of the square roots are going to be whole numbers. Some of the square roots are going to be irrational numbers. Some of the square roots are going to be decimals that are not irrational. Are y'all with me? So which ones do you call perfect squares? It's the one that when you take the square root, you get a what? Whole number. Are y'all following me? 2.25 has a square root. What's the square root of 2.25? 1.5. Is 2.25 a perfect square? No. Why is it not a perfect square? Because the square root is not a what? Whole number. Are you guys following me? All right. So we can find square roots of numbers, but we want to, what we're looking at or focusing on are perfect squares. Okay. So when we're simplifying square roots, we are looking for perfect squares within that number. So if I go back over here to radical 24, it's not on our list. So that means it is not a perfect square. However, that doesn't mean it can't be simplified, because it can be simplified. What I have to look for is think about all the numbers, all the factors of 24. Think about all the factors of 24, and I'm looking for any of them that are actually perfect squares. Because if they are perfect squares, I can pull them out. So, what are the factors of 24? Tell me the factors of 24. 2 and 12. What else? Isn't 2 times 12 24? Yes? 3 times 8. I'm talking about factors, not products. Not multiples. What else? 6 and 4. 1 and 24. Now, are any of these perfect squares? Which one? Is 6 a perfect square? What's a perfect square? 4 is a perfect square, right? Are y'all following me? So because 4 is a perfect square, look what I do. I go over here and I say, okay, I'm going to use that perfect square to simplify my radical. Pay attention. This is very important. Malia? Square root of 24. 2 numbers I multiply to get 24. 6 and 4. Y'all with me? Now, what is the square root of 4? This is very important. What is the square root of 4? Is the square root of 4 the square root of 2? Or is the square root of 4 the whole number 2? Whole number 2. The radical is gone now because I actually evaluated that. Are y'all with me? So the square root of 4 is the whole number 2. Guess what I just did? I just simplified the radical. How did I do that? I got it out of the radical sign. Are you all following me? Your goal is to make what's left in the radical smaller. How do I do that? By pulling out any perfect squares that I can make into whole numbers. Does that make sense what I just said? Yes? So now radical 6. Is radical 6 a perfect square? No. Are there any perfect squares in radical 6? No. How do we get 6? 6 and 1? 2 and 3. Are any of those perfect squares? No. So that means, Malia, I can't do nothing with that. So guess what I do? I leave it as a radical because I can't simplify it. Why can't I simplify it? Because there are no perfect squares in it. Are y'all with me? How do we simplify a radical? We find perfect squares that are in the radical and we pull them out. Does that make sense? Y'all with me? All right. So now what happens? I leave this as 2 times radical 6. I can't do nothing else with that because radical 6 can't get any simpler. So then I just write it as 2 radical 6. It's simplified. Does that make sense? Yes? I want to show you, prove to you that they are the same thing. Put this in your calculator. Put in your calculator 24. And then I want you to hit the square root key. What do you get? Okay, so let's just start with 4.8, right? 4.8 what? 9. All right? Now, put this in your calculator. Pay attention. Put this in your calculator. Put 6. Hit the square root. So we take the square root of 6. You got that number? Now put times 2. Equals. What do we get? 4.89. Are these not the same thing? They are. So they're the same thing. It's just this one is simplified, this one is not. And when you look at it, how do you know this is simplified? Because this radical is a 24. This radical is a what? 6. So it's been simplified. Do y'all follow? Yes? Now, do this in your notes with me. I want to do another example with radical 24 to show you that we don't have to do it exactly that way. So watch. On your papers, do this for me. Put square root 24. And now we're going to simplify it a different way. Let's say somebody does not realize that the square root of 4 is a perfect square, right? But they still want to simplify this. Give me two other numbers that I can multiply to get a 12. 3 and 4. 6 and 2. 1 and 12, right? Try to lean away from the 1 and something because it's going to end you up in the same spot, right? You still got to simplify 12. So let's try to break it down. So let's maybe do 6 and 2 this time, okay? So if I break this down, and not 6 and 2, not 6 and 4. I want to do 6 and 4. We did 4 already. 3 and 8. 3 and 8, right? So, and I'm listening to you. All right, so we got radical 3 times radical 8. I'm sorry, I'm trying to simplify 24, right? That's the same one we just did a minute ago, right? And I'm trying to, what did we just simplify?
You just said 12. Yeah, you did say 12.
Because Big Head said 12.
You said 12.
I kept saying 12?
Yeah, so you said.
Oh, I'm sorry, y'all. Oh, okay, sorry. I'm trying to, okay, so let's go back to what I said earlier. I said that I'm trying to do the same thing. Hello? I'm trying to do the same thing I just did, but a different way. Isn't that what I said? Okay, so then if I'm trying to do the same thing, if I did radical 24 before, I want to do radical 24 again. Okay, that was my mistake. All right, so let's go. Let's simplify square root of 24. So now we're going to use 3 and 8. Y'all with me? Now, think about your list that you got. Matter of fact, even if you don't think about your list, let's go. Can you simplify radical 3 down any further than it is right now? And here's a hint. If it's a prime number, it ain't gonna go no further. Y'all remember what prime is for elementary or middle school? Prime numbers is the only two factors is 1 and itself. Can any other number go into 3 but 1 in itself? No. So I'm just gonna bring down radical 3 because I can't do nothing else with that. Are y'all with me? Stay with me. Times. Now let's talk about this 8. Can I break the 8 down? Yes. What can I break 8 down to? 2 and 4. So I'm going to do radical 2 times radical 4. Notice everything is still in radicals. Why? Because I ain't simplified nothing yet. Are y'all with me? Y'all remember in, I don't know, where did y'all do this? Did y'all do it in elementary? Where you did factor trees? Yeah. Yes, and y'all would do like a number at the top, and then you do like the little thing, and then write 2 numbers, and then you break those off, and then write the next numbers, right? Prime factorization you had to do, same idea. Absolutely, absolutely. All right, so I'm here. Let's keep going. Are any of these perfect squares? Yes. What's the perfect square? The 4. And what is the square root of 4? 2. Is it the radical 2 or the whole number 2? So what I'm going to end up having is radical 3 times radical 2 times what? Whole number 2. Does everybody see that? Yes? Yes. Now, both of these are prime numbers. I can't do nothing else with these, right, Zion? So I'm just going to put them together. What's radical 3 times radical 2? Is it 6 or is it radical 6? So this is going to be radical 6 times whole number 2. Now that looks weird because we always write the coefficient, the number in the front, right? So let's clean this up. Let's use commutative to switch these around. So how do I rewrite this? 2 radical 6. And so we get the same answer. Same answer we got the first time. But we didn't use the 6 and 4 like we did the first time. This time we used 3 and 8. Y'all see that? Are you all with me? Yes? Any questions here? All right, now watch this. I'm going to take you another step further. This is essential. This is very critical content. Pay attention. What if I got all the way here and I did not realize that the square root of 4 was a perfect square? I want to show you something. I got square root 24. I think to myself, I need a 3 and an 8. No problem. Radical 3 times radical 8. Okay, I know I can't do nothing with radical 3. It's a prime number, so I'm just going to bring it down. Radical 3 times. But I know 8 is going to be 4 and 2, right? So I'm going to do radical 4 times radical 2. Don't matter which order you write them in. It's the same thing, right? Now I'm here, and it doesn't hit me that square root of 4 is a perfect square. Okay, but I'm going to keep going because I know I can break this 4 down. What can I break this 4 down to? 2 and 2. So I'm going to do that. I'm going to do radical 3. Now, instead of writing radical 4, I'm going to put radical 2 times radical 2. Now, these two radical 2s is for that's 4, right? So what do I have to write next? Another radical 2, because that's that radical 2. Y'all see that? This one is here. This is these two, and this one is that. Does everybody see that? Everybody following? Now watch this. I want you to do something. Put this in your calculators for me real quick. I want you to put in your calculator. I'm jumping off real quick to come back. Put in your calculator, square root of 5. So what are you going to hit? 5 square root. But then I want you to put times square root of 5 again. So do 5 square root again. Equals, what do you get? 5.
I got 6.
Wait. So we did square root of 5 times square root of 5, and we ended with the whole number 5. Y'all see that? Let's try it again. Clear it out. Put this in your calculators. Put the square root of 6. So 6 square root times the square root of 6 again. 6 square root.
I got 2.
And then put equal. What do you get? You keep forgetting to press equal. Square root of 6 times square root of 6 gives me, is it square root of 6 or whole number 6? Whole number 6. Are you starting to see a pattern?
Yes.
Yes. One more time. For those who ain't caught it yet. Let's do 10. What am I going to put in the calculator? 10 square root. So that's the square root of 10 times what? 10 square root. Come on, muscle memory. Do what I'm doing. Square root equals, what do we get? 10?
Yep.
10. Oh, you got it right this time. Times 10 square root equals, what do we get? 10. What is the pattern? If you multiply square root by itself, you're going to get that whole number. That's it. Are y'all following? But let me tell you what that is real quick. I don't have a lot of time, Jeffrey. So watch this. What is the square root of 5 times the square root of 5? Isn't it? It's not. It is 5, but isn't it also the square root of 25? Right? Because isn't 5 times 5 25?
Yes.
So the square root of 5 times the square root of 5 is the square root of 25. Well, what is the square root of 25? 5. Duh. Right? What's the square root of 6 times the square root of 6? Square root of, you got to say square root. Square root of what? 36. If you look at your list, what is the square root of 36? 6. Square root of 10 times the square root of 10.
100.
That's the square root. You're going to learn to say 100 one of these days. The square root of 10 times the square root of 10 is the square root of what? 100. What is the square root of 100? It's 10. Why? Because 10 times 10 is 100. So here's the idea. The idea is when you have a radical and it's being multiplied by itself, the two radicals, once they're multiplied, becomes that whole number. Are y'all following? Now take that thought and let's go back to where we was on our problem. So if we are here, we're here, right? What can I do? Think about what we just learned. I can multiply what? The 2's. I can multiply 2 of the radical 2's, and what they gonna end up giving me? The whole number 2. So what I got? Let's go back and look. I got radical 3. Y'all with me? Times, what's gonna happen with these 2? So let's see. What is the square root of 2 times the square root of 2? It's the square root of 4. And what is the square root of 4? Whole number 2. So this becomes the whole number 2, no more radical. Do y'all see that? That's what we just did. We said any radical times itself gonna give you the whole number, right? And now what do I do with this one? Do I make this a whole number 2? No, because I don't have another radical 2 to multiply by. So this just becomes what? Radical 2. Y'all see that? Yes? Tierra, yes, stay with me the whole time, baby. Does everybody understand what we just did?
Yes.
Oh, I'm trying to get rid of this. All right, so now I'm here. Now I need to clean this up. What I want in the front are whole numbers, and I want the radicals combined in the back, right? This is a prime number. Can't do nothing with that. That's a prime number. Can't do nothing with that. So I'm just gonna put them together. So let's rewrite this using community property. What do I write? 2, whole number 2, times radical 3, times radical 2. Now let's go ahead and combine those because I can't do nothing else with them. So what am I have? 2 radical 6. Absolutely. And if you got a number next to a symbol, that automatically means multiplication, right? And then that's how we just simplified that radical. We did it 3 different ways. Do y'all see that? All right, so what are the important things that I want you to remember from this? I want you to remember that the radical symbol with no number in it means square root, right? And what is the square root? It is when you take any number and you multiply it by itself, it's going to give you the number that's in the radicand, right? Levante, stay. Is everybody following? Yes?
Yes.
Now, if I'm given a radical, but it is not a perfect square, then I got to break it down. We got to use that factor tree, right? When I break it down, I can pick any 2 numbers, but they got to be written in radicals. When I see I have a perfect square, it comes out and becomes a whole number. I hope you follow it because I'm only doing it once. I'm not doing it again. This is it. It becomes a whole number. And then if you have no more perfect squares inside that other radical, you just bring it down. Are you guys following me? And that's how we simplify. That's how we simplify radicals. Is everybody following? Yes? Now, what was the other thing that we learned? Is that we don't have to use special numbers. You can use any numbers. As long as they multiply to give you that product, they're factors, you can figure it out. You can work your way to the same answer every time, right? Now, I want to look at what we did here. What did we learn here? That when you multiply a radical, Sarah P, by itself, what happens to that radical? It becomes what? It becomes a whole number. Is everybody good? Yes? All right. So now let's go a step further. I want to look at the paper. Pull out your paper that I just passed out to you.
Oh, good Lord.
Y'all gonna let me teach the class that I'm recording? Thank you. Thank you. All right. Number 1. I'm looking at number 1. We got A through I, right? So let's start with, real quick. Everybody should be able to write these quickly for me. A. Square root of 25 is what? 5. Square root of 25 is 5. Why? Because 5 times 5 is 25. All right, let's go. Letter B. Square root of 81 is what? 9. Why? Because 9 times 9 is 81. All right, now let's look at C real quick. C says 64 to the 1/2 power. Miss Stampley, what the heck is that? So watch this. I'm going to show you something. Anytime you have a number written to a fractional power, I'm going to show you how to rewrite it so that you understand it. Here's what it means. You're going to put the number inside the radical. Right? Are y'all with me? This exponent at the top stays at the top. Y'all with me? The one at the bottom is the root. It's telling you the root. So this is saying, I want the square root of this. That's it. Exponent stays exponent, but the bottom is the root. So it goes there. So let's say, for example, I would have gave you this. If I would have gave you 8 to the 1/3 power, then what am I giving you? I'm giving you the 8, inside the radical. But what's going to be right here? A 3, and the 1 stays here, 8 to the 1st power. But we know 8 to the 1st power is just what? 8. And 64 to the 1st power is just what? 64. So what do I really want here? I want the square root of 64. What do I want here? I want the what? Cube root of 8. That's all that means. Are y'all following me? What is the square root of 64? 8. Why? Because 8 times 8 is 64, right? So when we see this, that just means give me the square root. Are y'all following me?
Yes.
That's all it means. Now this, what is this telling me to do? Take the what? Cube root. Well, what is the cube root of 8? 2. Why? Because 2 times 2 times 2 is what? 8. So this is 2. Now, let me take you to the calculator. Y'all ready? Let's go to the calculator. Let's do the first one. Let's do 64 to the 1/2 power. Clear it out. Tell me what I'm gonna put in. 64. Now I got an exponent. Which one gonna be, which key am I using for my exponent? Y to the X. Y'all see that? So hit that. But now my exponent is a fraction. So what do I use to enter a fraction? That ABC. So what am I gonna press? 1 ABC 2 equals. What does it give us? Give us the 8. Yes, I'll do it one more time. All right, pay attention. What do we do, class? We're doing 64 to the 1/2 power, right? We're going to put in 64. We're going to raise it to an exponent. But the exponent is a fraction, so we got to use the fraction key, okay? So let's do it again. 64 y to the x, because you can take any number and raise it to a power, right? Y to the x. But dog, my power is a fraction. So I got to go over here and put the 1 in, because it's already at the top, right? But now I need a denominator. So I'm going to hit that, and then hit the 2. That's my exponent now. And then I'm going to press equal. But if you understand how they work, it saves you time. Are y'all with me? Hold on, I got a question. Yes.
When you press the 8, right, and you press the square root.
I didn't hit 8.
Wait, what'd you do?
I did 64.
Like 64.
Then I hit the exponent key. Then I put 1 as my first number in my exponent. But I need a denominator, so I did the fraction key, so I can get a denominator of 2.
Okay.
And then I pressed equal.
Alright.
Okay? Harold. Okay, give me the other way. Go ahead, baby. You did 64.
I forgot.
Let's try something else. What if we did 64? Y'all follow? Uh-huh.
First the second, and then the y.
Uh-huh.
And then you did
I'm sorry. I didn't hear you. Hold on. I did what?
y x, and then you press 2.
Hit the 2? 2?
And then you press equal.
That's all the same thing.
Oh! You know why? No, but why though? Because when you press second, you're doing the square root key. When you press second and press that, you're taking the square root. Remember we said this is the same thing as this. So what you're actually entering is this. We're entering this. Right? But it's the same thing. Right? I'm like, how you got that? Oh, because you hit the second key. So that's how. But yes, definitely.
Okay.
Right?
I understand that now. I understand now.
Yeah.
Class over?
Yeah,
That was the bell bell?
Yes.
Oh.
Remember we
All
were
right.
at lunch?
No, it's lunch at the end of the day.
Yeah.
Yeah. All right. So listen. Yeah. Just the front though. Everybody got it? Yes. All right.